Hello, everyone. I'm going to be title of my talk today is the interplay between mapping and understanding pedestrian access through an equity lens. Next slide. So, hey everyone, I'm Nick Bolton. I'm the founder of the Access Map and Open Sidewalks projects. My work has been on defining, gathering, and archiving community-driven pedestrian network information. So that's a lot of OpenStreetMap data, with a focus on accessibility analysis and information retrieval applications, usually maps. I've written a lot of software to support these efforts, ranging from websites to custom routing engines and to city-scale network analysis. Next slide, please. So first, I'm just going to say, what is a pedestrian network in particular? Next slide. So, put really simply, it's just where people can walk or use assistive devices to get around. Next slide. We use networks to describe transportation already, like for cars and trains. Pedestrian networks are an imposition of this same kind of model, but onto pedestrian spaces. Next slide, please. We know that this model is a little bit of an awkward abstraction for pedestrian spaces. That's because people can move on these spaces in many different directions, and they do that often. But it is still a useful abstraction that's amenable for communicating with one another as well as analysis. And in particular, a lot of aspects of computer science have been built around networks. And that's why a lot of routing tools work well with networks. Next slide, please. So why put pedestrian networks in OpenStreetMap in particular? Next slide. Well, first, quick clarification. We didn't create the first pedestrian network in OpenStreetMap. We're not the only people adding this kind of data to OpenStreetMap, but we are very active in making and using them as part of this kind of Open Sidewalks project. In particular, we try to do this in a way that accounts for pedestrian diversity. Next slide, please. So why put a pedestrian network in OpenStreetMap? Well, here's a couple examples. For example, everyone is a pedestrian, but actually very little data about pedestrian infrastructure has been mapped really anywhere. OpenStreetMap means we don't have to wait around for other people to map it. We can map it ourselves. Pedestrian data are also often kind of idiosyncratic, a little bit different from some of the other data, just in a couple subtle ways. And luckily, OpenStreetMap has a flexible data model that could potentially accommodate that. There's important use cases for pedestrian data that often impact what I would call low resource groups. This might be underfunded agencies, communities that are underserved, or developing countries that might not have the resources needed to do large-scale data collection and maintenance efforts. But OpenStreetMap publishes its data openly and has a robust free software community. This is something that can give an advantage for these low-resource groups. And finally, there's a lot of stakeholders that may want to have a say in the data. Think groups like governments, community activists, academics, and businesses all kind of have an interest in pedestrian data. And OpenStreetMap as a data commons could be a place for these groups to contribute data and constructively hash things out by just making the data better. Next slide, please. Next, I'm going to talk about the challenge when it comes to defining a flexible pedestrian network, and I'll talk about what that means. So the key challenge here is that pedestrians have diverse requirements. So people who drive or otherwise operate vehicles on roads, they also have personal preferences. But because vehicles and roads have been standardized for one another, this means there's a lot of categories of variation the drivers just rarely have to deal with. There's fewer of them, but there's quite a few that can pose a barrier or a significant deterrent for pedestrians. This is things like steep paths, raised curbs, stairways, a lack of infrastructure like marked places that are protected for crossing the street, or a lack of sidewalks. In addition, many pathways are often disrupted by a variety of things. It could be trees, or in this image, a pole that actually divides the path into at least two much narrower pieces that might pose a barrier to a lot of people. Next slide, please. In addition, this is a very common challenge for anyone gathering data or creating a new application, which is that data creation and data use are mutually dependent and reinforcing, which really means that there's kind of this chicken and egg problem when it comes to creating data that doesn't have a lot of use yet. We can't use data that doesn't exist. It's also hard to create good data without a very clear use case. So we landed on this kind of what I'll call a kickstarting strategy to try to create prototypes for both simultaneously and have them feed into one another and hopefully use that as a starting point. Access Map is an application for doing routing for pedestrians with a wide variety of requirements, and Open Sidewalks helps create and curate data via OpenStreetMap. Next slide, please. Now, kind of one of the main points of this talk is that pedestrian data must be mapped holistically. What do I mean by that? Well, we'll see next slide. With kind of a contrast, which is that most data, or at least a very large amount of data in OpenStreetMap, can be mapped bit by bit and incrementally in fairly clear ways. The wiki kind of reflects this. Most of the documentation describes how to map like a single element or to use a single tag. Even in the case where there's like a lot of subcategories and tags to be used in combination, someone that's edited the map can make one incremental change and successfully contribute in most cases. It's also at least somewhat rare that a mapper needs to think really deeply about the exact meaning of what they're mapping. It's usually relatively clear, even though everything isn't perfectly clear every time. As an example, mapping a tree. You add a node, which is a point where the tree is, and add natural equals tree. As a result, you go to the natural equals tree wiki page, and you get basically enough information to do this successfully. Next slide. Pedestrian data, in contrast, have a lot of interdependencies and are kind of interlopers into a map that already has a primary network. So as a result, this often means that pedestrian networks need to be mapping more things together at once in a very particular way in order for them to be, quote unquote, correct. As an example, I'm showing here an intersection where yellow lines are the street network and fuchsia lines are where maybe I've, drawn a sidewalk. Now, this has actually happened to us before. Maybe someone will now get grumpy at us because when I drew that sidewalk, I may have broken their routing. It used to route pedestrians on the street network, but now if their tool starts on my sidewalk network, well, it doesn't really have anywhere to go because it's not connected to the street or really anything else. Next slide. One thing I can do is I can add a pedestrian street crossing so that the network is connected. I've drawn a crossing that goes and connects to the sidewalk. Across the street, it's also connected to the street. Now I have no longer made that other person grumpy, but it means if I want to map a sidewalk, well, now I have to map two things. I have to map the crossing either simultaneously or before the sidewalk in order just to get that sidewalk. Next slide, please. But wait, actually it's more complicated. There's a curb ramp here. So what should I do about that? How do I map this kind of information for the pedestrian network? Some pedestrians will walk straight across the street, whereas others will need to use that curb ramp. Next slide. So often what we might need to do is actually map multiple paths that pedestrians will take. We have to imagine as mappers what a person might do in this case, less so than mapping just the infrastructure alone. So for example, I need to know where the curb ramps are in order to decide how I'm going to draw things like a crossing. When there might be, for example, two at a corner perpendicular, in that case, I might need to only draw two crossings, but in this case, I need to draw three at least distinct paths. Next slide. But to make matters worse, often, especially when we're doing armchair mapping, which is very popular, we're doing remote mapping, we don't know where the curb ramps even are. That's because the imagery is often too low of resolution, or often there are things like trees or buildings that obscure the view from above, and often there's just not any street level imagery available. Next slide. And so what can we do? Well, we can back up a little bit and say, hey, maybe we can try to build these things up incrementally. We can say, oh, I'm going to map slightly correct information, but indicate that it needs a survey later. One thing we could do is we could just go back and draw the simple crossings and say, straight across the street, I'm going to ignore curbs for now and throw it down. But how would we know that we need to come back and redo a survey in this area? One thing we could do is we could add a note, but then we would need to add a note, or several notes, at least 4 in this case, for every single intersection we map. Next slide. Well, one common strategy that's used in OpenStreetMap is to create situations in which you might expect there to be a tag added and then leave it blank. In this case, one way to do that would be to say, oh, well, I know where a curb maybe could be in the future, but I need to find some way to identify when that would be the case. So what I could do is I could split the crossing into 2. One part that's on the street and one part that's actually on the sidewalk. This could totally work. The place where they meet is a node where you'd be reasonably expected to add a curve potentially. But this also means now we have to think about what I'm going to say is ontological mayhem. we're going to have to confront the idea of like, is it a crossing that's on a street, it's on a sidewalk? This is a bit complicated. Next slide, please. But it could still work. So when someone does do that survey, well, finally, we can actually add sufficient information in order to build a relatively complete urban pedestrian network. Next slide, please. So in summary, that was a lot to keep in mind just to map one corner of one street. All I really wanted to do was map a sidewalk, and turned out I had to map quite a few things and go in a particular order. Even in the best case scenario where I knew where curves were, as well as curb ramps, I have to go in this process that in a very particular order. I have to know where are the curb ramps. I have to draw crossings from curb to curb that go through the curb ramps. I need to draw crossings that don't go through curb ramps. I need to draw sidewalks, and then I need to make sure those sidewalks are connected to all of my crossings properly for the on-sidewalk segment. Next slide, please. So my first initial conclusion is that we need good tooling and we need tags to help out with this. Basically, I'd say it's too difficult, or at least fairly difficult, to do this holistic mapping where you have to do quite a few things at once for pedestrian spaces. It can be done, and we do it actually pretty well, but it does take a significant amount of training and really careful checking. To make this practical and accessible by our communities, we need mapping tools that guide and simplify this process, and tags that help us out. As a temporary workaround, the Open Sidewalks project has developed some documentation and tutorials to assist this project, and uses the HOT tasking manager to break down units of work. For example, separate projects that break down a crossings mapping task and a sidewalks mapping task. But more is definitely needed. We definitely need things like editors and QA support, maybe even bespoke editing processes to support this. We also need these tags to help distinguish on-street and on-sidewalk portions of a crossing. These are not tags that are standardized or documented in any way. We also might want to look into a new strategy, which is to try mapping out pedestrian spaces as areas first, which I'll talk about for a second. Next slide, please. So one alternative that we could do is, instead of mapping out all of the things that we could imagine imposing a network on the space for, is we could just map out the surfaces. Here I was showing that I only needed to map out 4 surfaces, more or less, to describe the same kind of thing. There's sidewalk in fuchsia, I've mapped out the curb ramp as an area, and then these 2 crossings here. This approach here to describing the infrastructure on the ground is also super compatible with computer vision approaches, like the ones that Ricky talked about. Next slide, please. After we had this data, it could be downloaded, and then the same paths inferred using pretty standard and fairly ubiquitous approaches used already in computer science, robotics, and so on to discover paths when you're actually using surfaced kind of data. Next slide, please. This might actually be easier because before, like I mentioned, there's only 4 surfaces mapped here, but we had to map actually 11 separate kinds of distinct paths in order to represent the network before. Next slide, please. But for now, we are doing that 11 paths mapping, and it does work. Next slide. Now, what can we actually do with this data once we have it? I've talked about the challenges and the details involved, but what are we actually doing? Well, even though I said it was difficult, we are mapping out a lot of data. Open Sidewalks in particular has mapped out fully these 3 cities, Bellingham, Mount Vernon, and Seattle, and with our partners in the community, also San Jose, and a lot of other projects across the Americas, both North and South America. In addition, there's a lot of people mapping sidewalks and this kind of information who aren't affiliated with our project and are doing great work. Next slide, please. And what can we do once we have that data? It needs to be at that city scale, it needs to be flexible, but once we have it, well, we can do things like accessible trip planning. Like a popular tool like Google Maps lacks pedestrian-specific data and appropriate logic for handling that data. In panel A, we're looking at Google Maps, and it says, hey, you should cross this busy street at a location that has raised curb, no mode. This would be like a complete no-go for a lot of people, including many manual wheelchair users. Whereas our tool here, on the right, Access Map for panel B, it recommends the use of a marked crossing with pedestrian signals and curb ramps. This is a combination of just knowing what kind of information is there and how to interpret it appropriately for pedestrians with different needs. And this is coming straight from data from OpenStreetMap. Next slide, please. In addition, when we have like a city scale network, instead of saying, how can I get from point A to point B on the infrastructure, we can say, how well does infrastructure support different people? So here I'm showing a fairly complicated tool, but it's basically just showing a watershed, saying if I started at this tiny blue point in the middle as someone who has no particular requirements as a pedestrian, and I can go 1,000 feet, what are all the places I could get to starting at this location downtown Seattle? And because it's relatively unconstrained, we get this pretty large ball or diamond shape that shows you can get to quite a few places. Next slide, please. But if we instead change our profile and say, well, what if I was this stereotyped manual wheelchair user who can't go greater than 8.3% uphill or greater than 10% downhill and requires the use of curb ramps or at least avoiding raised curves? Well, now we get a much smaller area that's more like a line. And this is because downtown Seattle is very steep going in the opposite direction here. In addition, we can take these kinds of analyses and we scale them up quite a bit. In addition to these blue lines, we have this heat map in the background. This is all these places where we have calculated this kind of scoring mechanism for every single street in the entire city to show how does it vary if you were to start these locations. Next slide, please. And this network effect is really valuable. Doing a network analysis is much more valuable, and this is the kind of thing we can get when we map this kind of network in OpenStreetMap. On the left is showing a more traditional analysis approach to sidewalk coverage in a city. Cities do sometimes collect information about their sidewalks, but they say things just like, hey, how many sidewalks does the street have? 0, 1, or 2, like one on each side, or just one on one side, right? And if we look at the plot on the left, it's showing Seattle. We could see, oh, there's quite a few sidewalks streets that are yellow here, meaning they have 2 sidewalks. And then maybe towards the very top of the city, the north side of the city, there's places that don't have a lot of sidewalks. And that's kind of all the information we have. But if we do a more network kind of approach where we understand these walksheds and this kind of walkability approach at this highly granular level, we can see, oh, actually, there's a lot of variation and subtlety out there. There are places that actually are a lot harder to get around in that would have just looked easy to get around in. And this is because of connectivity and infrastructure issues. Next slide, please. In addition, I can talk about equity. So in some of these previous examples, I was showing things like just via some absolute quantity, how easy is it to get around? How many places can you get within 1,000 feet and that kind of thing? But because we can also group these results, maybe by street, or in this case, I'm showing by census tract, we can compare the experiences of different people or stereotyped profiles across the same space. So we can say not only, oh, area is not that easy to get around in for someone who uses a manual wheelchair, we can say, oh, it's also much easier for someone who has a more normative experience with no requirements to get around. And we can compare this to a situation where, maybe actually it's not that great for everybody. And this is valuable for seeing where there are places that impact different people to a greater degree. Next slide, please. So in conclusion, we can and we do collect pedestrian networks straight in OpenStreetMap. Doing so in a way that's flexible and also friendly with existing data is pretty difficult. Maybe someday we'll begin mapping things like areas, but until then, we can map whole cities using our documentation, community outreach, and the tasking manager. At the same time, we do still need better tools, QA, editor support, tags. But once we have that data, we can begin answering some key questions of pedestrian access and equity. Next slide, please. And that's it. So thank you all. You can find me at NJ Bolton on places like Twitter and so on. Best place to contact me, though, is my email, which is nbolton@gmail.com. You can also join the general kind of sidewalks Slack at OSMUS, or check out our website at opensidewalks.com. And thanks all again for putting this together and for having me.